Okay, well, we'll make a start. So, yeah, hopefully you can see the screen okay and see all the slides. As I say, hit fit to frame in the bottom left if not. The CPD today is our CPD focused on non-residential and Part L. We run 4 CPDs a month like this. The other ones we do are for residential new build. We also do retrofit and social housing decarbonisation CPD, and also one focused on installation and sort of technology overview, sort of more hands-on installation side of things. So there's one each Thursday in the month. As I say, today's is the non-residential focus. But yeah, please do join the other ones if they're interested. So I'll go through a little bit about who uses wastewater heat recovery, what it is, some of the products, some sort of case studies, just touch on some of the modelling of wastewater heat recovery, and that should take us through to almost an hour or so. So who uses wastewater heat recovery? Well, predominantly in the UK it's been house builders. So for the last 10, 12 years or so, residential new build house builders. So Recoup's been supplying wastewater heat recovery into the UK for all of that time. Quite lucky to get contracts with Barratt's from about 2012. So we've been supplying them in some of their developments for some house types since about 2012. So although it's a new technology to a lot of people in the UK, it's not actually a new technology as such. It has been around for some time, and in the UK, Recoup's been around as long as anybody. It's also been used quite widely on the continent as well. So it's new to quite a lot of people, but it's actually quite a technology that's been around for quite some time, actually. So builders have been using it for Part L compliance in apartments, bungalows, passive house, etc. But more recently, and what we're looking at today is wastewater heat recovery in kind of non-residential projects. So we see it used now a lot in hotel and student accommodation projects for building compliance and meeting energy targets, and for domestic hot water cost reduction, or ongoing domestic hot water cost reduction. Also, a large area of growth for wastewater heat recovery is leisure and sports facilities. As you can imagine, sort of very high shower use environments benefit from domestic hot water cost reduction. And wastewater heat recovery can even mean plant size reduction and a cost-effective measure for a method for compliance with energy targets. These sort of high traffic, high shower use areas really have great ROIs. And again, quite recently we see offices, so a lot of office projects, particularly in London, are incorporating showers as a facility for staff, and wastewater heat recovery can work really well there, mitigating quite significant domestic hot water costs where traditionally they maybe weren't a consideration. And yeah, finally, manufacturing, so particularly food and pharma environments, showering is becoming much more commonplace as a standard sort of hygiene routine, or part of the routine for kind of maintaining sterile conditions. So to say, why use wastewater heat recovery? What's really driving it in the UK is the changes to Part L building regulations. Although it's been around for some time, not so widely adopted. As I say, we've been supplying Barratt's on the residential side for a number of years. Redrow and some other developers have adopted, but it's the changes to Part L coming into the Part L 2021 which is really driving its uptake. So the change to building regulations came into force on the 15th of June in the form of 2 new approved documents, been slimmed down from 4 parts into 2 volumes, Volume 1 for dwellings and Volume 2 for buildings other than dwellings. And these are just an interim step towards the future home standard and future building standard that will come in 2025, which will call for even greater uplifts. As part of those changes, non-domestic buildings now required to meet a target primary energy rate from either renewables or non-renewable sources, and they're high performance targets. So CO2 emissions are reduced by 31% for dwellings and 27% for other buildings. So this is what's really pushing the uptake of wastewater heat recovery for those buildings where there's showers. In addition to that, we see a lot of kind of local plans, particularly London Plan, which asks for an uplift over and above the minimum requirements for building regulations. Particularly with London Plan, as I say, that's kind of really driving the uptake in London with wastewater heat recovery. So non-residential developments should achieve at least a 15% improvement on building regulations from energy efficiency measures alone. So you can see as part of the B lean part of the guidance for the London Plan, as an energy demand reduction measure, wastewater heat recovery really kind of ticks that box. So much so that the guidance actually even prescriptive in saying that wastewater heat recovery must also be investigated and set out in any energy assessments. So that's what's really driving the interest in wastewater heat recovery and the uptake of it at the moment. So why use it? So it's significant energy and CO2 reductions, very easy to incorporate into a new build scheme, or minimal adaptations for integrating into an existing infrastructure. Significant hot water cost reduction. So domestic hot water requirements per shower can be reduced by up to 55%. So less domestic hot water used per shower use, and it's fuel agnostic. So it's equally applicable to where you've got gas, electric, air source heat pumps, HRUs, combi boilers, whatever it might be. It's a heat source agnostic technology. And also, as I mentioned, domestic hot water plant size or cylinders can often be reduced in size. It's one of the cheapest and most cost-effective measures available in SAP and SBEM. So when you're comparing it to things like PV on like a points per pound basis, it's really competitive. So it's a very cost-effective measure for compliance. And as I say, very easy to design in compared to most alternative measures, and we can support with that. So if you have projects, floor plans that you have and that you're working on, you can share them with us. We can make suggestions and help to design in the best sort of system for you. Quite crucially, it's completely fit and forget. So it's a completely passive system, so there's no end user interactions required. So there are no controls for anyone to learn. Nobody can switch it off. It can't be bypassed, so it just works every time someone has a shower. So once it's installed, it's just there and it just works. So there's no end user interaction at all. Most people who have wastewater heat recovery in the home or in an apartment or student accommodation, whatever it might be, they don't know it's there. It just does its thing in the background. There's no planned maintenance, so with all but one of the systems, we have no electrical connections or anything like that. There's no moving parts, filters or consumables. So with no planned maintenance, as I say, it's just fit and forget. Has a long working lifespan as well. So what were bays have attributed a working lifespan of 40 to 60 years on the vertical pipe systems. So in line with the plumbing infrastructure. So again, compared to other kind of technologies, it's because it's so simple, it has a really working long lifespan. And it has a low embodied carbon as well. So we have cradle to cradle manufacturing process. We'll look at that a little bit later. I've got a couple of slides on that, but it's very low embodied carbon product. And we have the certifications you'd expect. So SAP, SBEM, you can get BREEAM points on it, and PHPP listed and RAS listed products as well. I will say the products we're going to look at today in the sort of case studies focus on the instantaneous localized wastewater heat recovery products we offer. We're not looking at kind of centralized or plant-sized systems. These are all systems which are localized to the showers they're connected to. So they have high efficiency, they're low system losses, they're all passive, so say no mechanical, electrical parts, and there's no planned maintenance with them. In the UK, the sort of centralised plant-sized systems are not that commonplace, and not something we offer at the moment. Saying that, we do have the option to potentially become a distributor in the UK for a centralised wastewater heat recovery system. As I say, it's not something we offer at the moment or we can really support on, but it would be interesting to hear from you if you have got projects where it could be applicable. So if it's of interest, please do let us know. Pop something in the chat section. Mention the chat section on here. If you've got any questions, pop them in the chat. I should have said my colleague Chris is in the background and he can answer any questions in the chat section. So please pop any questions in there, and I'll try and cover them at the end as well. So how does wastewater heat recovery work? It's simple heat exchange technology. So we don't harvest any water, we don't store any water, so that you don't get things like any smells, or there's no grey water harvesting, anything like that. It's purely a heat exchange technology. So it's a counterflow heat exchanger. Shower wastewater enters one side of the wastewater heat recovery heat exchanger at the same time as mains cold water simultaneously enters the other side of the heat exchanger. And the heat energy from the hot shower waste is transferred via the heat exchanger into the incoming cold mains water. So we preheat that incoming cold mains using the heat from the waste shower water. The now cool shower wastewater exits the heat exchanger to waste, and the preheated mains water can then be used in one of 3 different ways. So we're just literally preheating the incoming cold water using the heat from the outgoing wastewater. The two never mix. So we don't harvest or store any of the wastewater. It's just transferring the heat from wastewater into the incoming cold. So as I said, there's 3 recognised ways to use that preheated water. They're known as System A, System B, and System C. All they do is denote what you do with that preheated water. So there's 3 different ways you can use it. So once the preheated water leaves the wastewater heat recovery system, you can either install a System A, System B, or System C. So System A is the most efficient installation method. So you can see on the schematic here with System A, we take that preheated water and we send it to 2 places. So the preheated water leaves the unit and it goes to the cold side of the shower's thermostatic mixer valve, and it goes to your hot water source. So that hot water source could be, as I said, a combi boiler, a hot water cylinder, an HRU, doesn't really matter. So that's your System A installation method. It's the most efficient installation method because you're sending the preheated water to 2 places. So you're sending it to your hot water source and you're sending it to your cold side of your shower mixer. So when you send it to the cold side of the shower mixer, the mixer will automatically adjust the ratios between hot and cold. So you use less hot water and more of the preheated cold. So normally you're sending, when you don't have wastewater heat recovery, your 40-degree hot water at your shower head is made up of a mixture of about 70% hot and 30% cold. When you send it preheated water, you're now sending it water at, say, 25, 26 degrees rather than 10 or 12 degrees. And the valve, the thermostatic mixer valve, will adjust those ratios to almost the opposite way round. So you will be getting a mix of about 70% of the preheated cold water and only 30% hot water. So you instantly using less hot water. And then because you're sending it also preheated water, sending it also to your water heater, the hot water you are using is now only being heated up from about 25 degrees, as I say, rather than from 10 degrees. So the hot water you are using is requiring less energy to produce it. So that's the most efficient method, System A. As I say, that's not always applicable or not always able to be used. So, for example, where you've got centralised hot water, you wouldn't be able to use System A because you can't be sending all your preheated water back to your sort of centralised hot water plant or through multiple wastewater heat recovery systems. So where you can't use System A, the second sort of system we normally look at is System B. So System B differs in that you're only sending the preheated water to your shower. So you're not sending preheated water back to your hot water source. You're sending it to the cold side of the shower's mixer valve only. It's not quite as efficient. We'll look at how much less efficient in a minute or two, but it's not too much less efficient. But it is a much more simple installation method. Everything's isolated from your hot water side, so it's purely localised to the cold side, and it still offers really significant savings on your hot water use. And it's a much more simple installation method than, say, the only one that's really applicable where you've got a centralised hot water. And then lastly, you've got System C. In terms of efficiency, it sits between System A and B. We don't see it used that often for kind of non-residential applications. You get a few kind of specific niche situations where it might be considered, but it's the least common system to be used, and it's where you're just sending preheated water to your hot water source only, so you're not sending it to the shower. As I say, it wouldn't be specified that often, occasionally in specific circumstances, but you're normally looking at System A or B in most cases. Just to recap on those: System A, System B, and System C. System A, you send the preheated water to your hot water source and your shower, most efficient. System B, you send it to the shower only, so applicable for centralized hot water, or for where you've got a system A already in the building, you can only have one system A, so any secondary would be a system B, and then system C, as I say, you don't see so often, where you're just sending the hot water to your hot water source. So what does that equate to? So this is looking at the Pipex. So this is our vertical Pipex system. It's the most efficient, sort of cost-efficient product we supply. You can see there a flow rate of 11 litres per minute at 40 degrees C. You can see an energy demand reduction there of about 54%. As you drop the flow rate, so down to 9 litres per minute, that energy demand reduction increases. You're getting close to sort of 58%. That's because, like any heat exchanger technology, the slower the flow rate, the more efficient the heat exchanger gets. So if you're running at 5 or 6 litres per minute showers, you'll get an even greater saving. And we're seeing a move towards a lot lower shower flow rates, so the impact is even greater then. So yeah, the lower the flow rate, the greater your impact will be, but you can see there's a very significant saving in the energy demand per shower there. Versus system B, so that's a system A on the Pipex. If we look at system B, you can see it drops a bit, but it's still significant, so maybe drop 10%. So with system B, it's a hot water demand reduction, so you're dropping to, say, about 10% less than you would be looking at on equivalent flow rates for system A. So it's still a significant impact there of sort of 11 litres per minute. You're looking at, say, 44% efficiency, and at 9 litres per minute, you're looking at about 48% reduction. So still very significant. You can see on the right-hand side there, that's a snippet from the PCDB, the product characteristics database, where our products are listed. So all of our products are third-party tested at Kiwa, which is in the Netherlands. It's the kind of centre of excellence for wastewater heat recovery in the Netherlands, where it's been used probably for the longest. So the products all tested there. That data is then used by BRE to populate the PCDB, which then gets fed into SAP and SPEM. So all these figures are sort of third party tested and validated. Just recap on that. So installation time, 1 to 2 hours for most of the products. Only basic plumbing tools and materials are required. There's no specialist training or commissioning. No planned maintenance, so sort of simple routine cleaning if required. So things like standard domestic drain cleaners can be used. There's no issues with using those at all. There should be no need to use them any more regularly than without wastewater heat recovery, but they still can be used. And no behavioural changes, so it works automatically every time you shower. No user interaction, as I said. So that's kind of a wastewater heat recovery generally. We'll have a look at a few products types and how they can be used, and sort of some sort of simple or quite brief case studies of where they've been used, and we'll just have a look through those. So the Recoup Pipex is probably the most specified product. It's been used for a number of years by most of the residential builders, but it's also a really good product. We see it used a lot in hotels where we have things like service risers and that kind of thing, so we'll have a look at that in a moment. It's a vertical pipe system, so approximately 2 meters tall. You see it here in a residential setting. So I've got this slide in here, though it shows it in a house. You can see it boxed in next to the SVP. It's nice. It kind of shows a cutaway with the shower above, with the waste coming from the floor above on the shower into the top of the Pipex. So it's designed to go on the floor below the shower that it's connected to. So it's a gravity-fed system on the waste side. As I say, it's the most specified product we have because it's the most efficient, and as I say, cost efficient as well. So very high efficiencies, up to 63.6% at 11 litres per minute efficiency on the heat exchanger. We get those efficiencies partly because of our turbo rotator, which is the device on the top there, which you can see in the image. It's this which directs the flow of waste into the pipe. It makes it cling to the inside of the heat exchanger, and we get a thin film heat exchange, and that's what helps to give us our high efficiency. And hopefully this video will play. Yes, it is. So this is a turbo rotator cut open, so you can see it from above. You can see the wastewater as it goes down the turbo rotator, makes it spin round in a cyclonic motion, and it clings to the inside of the heat exchanger. Obviously here we've replaced the heat exchanger with a clear plastic pipe, but you can see how we get that sort of thin film heat exchange as it clings to the inside. It also means we don't get any falling water noise or anything like that, because it's not just dropping down the middle of the heat exchanger, it clings to the inside as it rotates round. It's a simple first fixed installation. We have solvent well connections on the waste side, connection to the mains, cold and preheated pipework using 1/2-inch male BSP connectors. We don't supply those, so they do need to be supplied, along with a double check valve and a pair of full bore lever shut-off valves as well. One thing that's quite important to mention with our products, they're all double wall heat exchanger construction. So that means we directly comply with UK water regulations. We also have a visible leak detection system. So as well as being a double-walled heat exchanger for compliance, we have a visible leak detection system, and that also means we're kind of a belt and braces approach to compliance. You might be able to see on the cut through of the pipe there, you can see that that's one of the pipes which has been cut through. There's some small striations around the top of the pipe, where those striations run the whole length of the pipe. So if there was ever to be a puncture or anything of the heat exchanger, we'd get visible leak detection at the bottom, because the water would run the length of those pipes, drip from the bottom of the pipe, and we'd get a detection that was kind of first fix and pressurization. In practice, we've never actually had one leak, because they're all pressure tested before they leave the factory, and they can be pressure tested up to 10 bar on site if need be. But yeah, in practice this never happened, but we do have that leak detection system there, and that double wall heat exchanger construction as a sort of kind of belt and braces method to compliance. I mention it just because not all products on the UK market have been double walled heat exchanger and have that direct compliance with the water regulations. So if you don't have that, it can mean you have to do things like move the shower trapped downstream of the wastewater heat recovery unit, rather than being where it should be on the shower. It means you can get things like falling water noise and that kind of thing if you have to do that. So it's worth just, if you are comparing products, just making sure that you are looking at kind of double walled heat exchanger products to compare with. So as I say, we see the Pipex used a lot in residential new build, but also we see it specified quite a lot now in hotel projects. So I think one of the first was the redevelopment of Camden Town Hall to 270 bed hotel. It's designed to achieve the BREEAM status of very good. As I say, one of the first UK hotels to install wastewater heat recovery to the majority of its rooms. It was an Arup design. I think we might have some people from Arup on here today. The Arup design utilised 2 showers to 1 wastewater heat recovery pipe, so 2 to 1. As you can see on the sort of schematic there, the pipe located on the floor below the 2 showers connected to it. So obviously that really makes it an even more cost-effective measure, and gives it a great ROI. And that has no impact on the energy savings or compliance. So if you can get 2 showers into one like this, anywhere you've got service risers, it's a really, really good way to integrate it, and it's kind of become a bit of a blueprint for how we see wastewater heat recovery being built into hotels and that kind of thing, where you've got these service risers that lend themselves to it. That's been installed since about 2019, and domestic hot water demand for the showering has been reduced by about 42% in this case. So yeah, it's really quite a significant impact when you think the amount of hot water used for showering in hotels. Arup have written actually a white paper on this, so transforming existing hotels to net zero carbon, where it concluded that it strongly recommended wastewater heat recovery for new hotels or major refurbishments. So that's worth a read if you want to have a look for that on their website. You can also install 2 to 1, so 2 showers to 1 Pipex, where they're stacked showers maybe. So 2 showers on different floors. We've also seen this done in hotels. So rather than back-to-back showers, you can have them stacked showers connecting. Anyway, you've got 2 showers to 1, then obviously attention needs to be paid to the flow rates and length of pipe runs. So you need to pay attention to that anyway, but more so where you've got multiple showers connected to one wastewater heat recovery unit. The Pipex on a System B install, which is typically what you'd see for, say, a hotel where you've got centralised hot water, is sort of 22 to 24 litres per minute. So you can still get 2 quite nice shower flow rates connected to that, and have no problem with a limitation on flow. There is a limitation in terms of the maximum pipe run you can have from the preheat out of the wastewater heat recovery unit to the connected shower. So when the pipework leaves the preheat pipework leaves the wastewater heat recovery unit and goes up to the cold side of the shower mixer valve, that length must be no longer than 4.75 linear meters in 15 mil. That's a Legionella measure, so that maintains the lowest possible Legionella risk compliance. It means the volume of water held in the pipework is minimised. On Legionella, it always gets asked about with wastewater heat recovery. All of the products and all of the system types we have are all independently Legionella control risk assessed. So we heat the water to around 25, 26 degrees, something like that. So it's at the low end of the sort of Legionella growth range. And as long as they're installed within the recommendations, then each of the products and the installation methods are considered lowest possible risk. So as I say, we have those Legionella control risk assessments we can supply. If you go outside of those, then it just means needing to risk assess it separately. But they're considered lowest possible risk if installed within our recommendations. There is no zero risk with Legionella. Lowest possible risk is as low as you can get. But as I say, it's something that always does get asked with wastewater heat recovery. Normally the standard pipe hex is sufficient. So even where you've got quite high flow rates, we have done high flow rate testing with it, and normally the standard pipe hex is great for even very high flow rates. If you really have got exceptionally high flow rates, we do have other vertical pipe products, some high flow versions available. As I say, they are quite niche. We've seen the odd hotel project, very high-end hotels with some kind of flow rates absolutely through the roof, and they could be applicable in those sort of situations. But generally, they say they are quite niche, and the standard pipe will do the job. But the thing is just to come to us, and we can help spec the right product. We also have some slightly different length versions of the pipe hex. So again, the standard pipe hex, most of the time where you've got service risers or standard ceiling heights, is going to be absolutely fine. However, we do have an RD version, which is a reduced height version, which is about 1700 mil long rather than the sort of 2.3 of the standard version. So if you have an issue with space, then the shorter RD version might work. We also can do bespoke lengths. Obviously, minimum order quantities and things could apply for bespoke versions, but we can make different length versions if need be to go in specific size spaces. So as I say, normally again the standard pipe hex is fine, but we do have other options if there are limitations on space. So the pipe hex is great where you've got floor below the shower that it's connected to, because it's gravity fed and it needs to go on the floor below the shower that it's connected to. So it's great in that situation. It's highly efficient, vertical system, so it's perfect. It's kind of the first go-to product. Obviously, that's not always the case. You can't necessarily have the waste heat recovery unit on the floor below. Maybe there's ownership issues around putting infrastructure on the floor below, or you don't have service risers, that kind of thing. So where you haven't got that, the Easy Fit is kind of our next go-to product. The Easy Fit is a horizontal system. So it's not quite as efficient as the vertical pipe system. Horizontal systems never are, but it still has a big impact. It's really effective in things like apartments, student accommodation, that kind of thing. So it's designed to go under the bath or under a riser shower tray. So you can see here the efficiency is 43 to 47% efficient, so not quite up there with the vertical pipe system, but still quite impactful. As I say, designed to go under a bath, but it can also go under a suitably sized riser shower tray. I think it's about a 1400 mil long tray. It needs about 110 mil of height clearance. So as I said, great for sort of hotel, student accommodation, apartments, that kind of thing. And also a really good retrofit option. So whereas the pipe hex, you can imagine, is great for a new build or kind of a deep retrofit, if you're just doing kind of bathroom refurbishments, that kind of thing, it might not be so easy to get access to install the pipe hex within the sort of the service risers or floor below kind of thing. But where there's with the Easy Fit, where you can put it under a bath or a shower tray, it kind of lends itself much more to a lower level of kind of retrofit. Works in exactly the same way as the pipe hex, so it's a counterflow heat exchanger. Wastewater goes in one end, comes out the other end, and in the opposite direction, cold mains comes in, comes out preheated. It's quite flexible in how you can install it, so we've designed it so it doesn't really matter which end your your shower waste is in relation to, say, your SVP or your stack. So it can be orientated whichever way you need it, and it's designed so that it's kind of stepped, so you have room to run a waste pipe from one end to the other if need be. So you can see it's quite flexible in how you orientate it. You can kind of just make out there under the bath that you kind of has a stepped design, so there's room to run a waste pipe from one end to the other if need be. And similarly to the Pipex, even though it's a vertical system, there's no planned maintenance required. So the system was designed from the ground up not to block or become snagged. So it has an open, flat heat exchanger design within the EasyFit. So water was designed to spread out across the width of the EasyFit, and then to drain freely out once the shower stops. So again, no planned maintenance, but you can again still use normal domestic drain cleaners in it. There's no reason why you couldn't. But again, you shouldn't need to any more than without wastewater heat recovery present. Obviously, under baths, you do sometimes get a central leg. So where that is present, then you may need to remove the central leg. There are plenty of baths out there that don't have central legs as well, but if you do, then you can get these universal leg kits which can brace it. You don't need to use these. You could just brace with timber if the central leg has to be removed, but there are these leg kits on the market that are available for doing that if needs be. We've used them in some of our demo rigs here, and they're pretty good. So just another little case study. This one's actually, I published this on LinkedIn, a more in-depth version just a couple of days ago. So if you want to have a look for it on there, it's on there in a bit more detail. But this is Cramner Road for King's College, Cambridge. They used a combination of the Pipex, and where they couldn't use the Pipex because it was on the ground floor, they've used the EasyFit. So as I said, the Pipex was located on the first floor, being fed from the showers on the first floor above. Then the EasyFit was used to service the showers on the ground floor. They used this with instantaneous electric domestic hot water. So it was a passive house, designed to passive house standards. So it was a very low energy development. So you used instantaneous electric domestic hot water for each of the rooms. Designed to be very lean and minimise the internal heat gains, and the wastewater heat recovery worked really well with these. As I said, the Pipex was on the ground floor feeding the showers above, so again they managed to get it a 2-to-1 design, so again made it very cost efficient. And then on the ground floor, because they couldn't use the Pipex there, they used the EasyFit, and these were designed into the bathroom pods. So they had the shower pod. You can see there the EasyFit fitted partially underneath the pod, and then the part of the EasyFit that wouldn't fit underneath was then within a service cupboard which was to the side, so it could still be accessed from there if needs be. So it's a really nice design to integrate that into the ground floor showers. It was a continually monitored project as well, so that it is being monitored to see the energy use that's going on there. It was interesting because the kind of the initial data from it is showing the actual hot water use is more than expected, but that's because the PHPP software used for modelling it assumes a 5-minute shower duration, and they're actually finding that the students actually shower for longer than that on average, so around 7 to 8 minutes. So the hot water use is actually higher than they expected, but actually that means the wastewater recovery is having even more of an impact because the hot water use is that much higher. So that's the EasyFit product, the horizontal EasyFit. So between the Pipex and the EasyFit, they cover a lot of different scenarios. We do have the drain range as well. So these are the products we see specified most in things like gyms, leisure centres, that kind of environment. So where you have banks of showers generally. They're a bit more expensive than the EasyFit and the Pipex, so they have kind of a higher upfront cost, but they can have a really great ROI where you've got these kind of high shower traffic use environments. So, I say gyms, leisure centres, that kind of thing. So they're an in-floor drain system. So they're built within the floor structure. So they're fixed there permanently as part of when the floor's laid. So they replace like any other kind of linear wet room or drain channel. so they're part of the floor structure. You can see on here there's a couple of different kind of finishes we have. So we do one with a stainless steel perforated top plate. We do also one where you can tile it as well. So we've got a couple of different options in terms of the finish. Very efficient, so slightly less efficient than the Pipex, but you see still up to 57% efficient, so still very effective. As I say, we see them used largely in gyms, leisure centres. Anyway, you have banks of showers, but they can be used in sort of residential as well. Anywhere you've got a tiled floor. As I say, where you've got high shower traffic, really can have a great ROI. So quite common to see sort of a 2 to 6 year return on investment on these for gym and sports facilities. But we've seen examples where it's been even better than that. So we've got these installed in gym box, and their predictions for return on investment on that was just over a year, just because of the amount of showering they do. Low shower flow rates, high shower traffic. Really meant it had a real impact. So there's a few different models of these. Looking at the Drain Plus Duo and the Drain Plus Duo HE here. So as you might expect, the HE is the higher efficiency version. Slightly larger than the standard Drain Plus Duo. So it's slightly bigger, slightly deeper, so requires a slightly bigger floor depth. But they work in essentially the same way. So the shower wastewater enters the top. It drips via a percolation plate over the heat exchanger, the copper tubed heat exchanger inside, transfers the heat. The shower wastewater flows out to waste, and your preheated water goes off to feed your shower, or potentially hot water supply, but usually just the shower in the case of these, with preheated water. So you can see there's the Drain Plus Duo and the HE. The HE's got that much deeper. It's got a double layer heat exchanger essentially, so it's that much deeper to accommodate the sort of the 2 layers of heat exchanger in there. As I say, you can see quite impactful in terms of efficiencies. So say not quite as efficient as the vertical systems, but still significant. You can see in the little cutout images there, you've got the 2 different sort of finishes for the top. So you've got the stainless steel cover plate which has got perforations in the top, or you've got the tiled cover plate. So you've got the option of either one. The tiled one's nice, so quite often architects like to keep the slip rating of the floor the same throughout. So if that's important, then you can go for the tiled option, and I say maintain that slip rating. This just shows, similarly to the other products, that they need to be used with a pair of full flow isolating valves and a double check valve. On this image we show them located right next to the drain. They don't need to be positioned so close to the drain as that. They can be positioned more remotely. Normally these are only used at end of life, possibly when isolating if you need to for pressure testing. They can be pressure tested up to 10 bar, so if you need to pressure test higher than that, they need to be isolated. But generally just end of life use, so they don't need to be positioned right next to the drain like this. We show them like this just for ease of demonstrating on an image, but quite often they're positioned somewhere where they can be accessed. And you can see the drain comes with the levelling feet, so it can be levelled and positioned before being having sort of being backfilled within the floor. And they come with a horizontal waste, so you can see the sort of the waste siphon in the top right there. This can be rotated 360 degrees, so you can see on the image at the bottom there, you can see the waste coming out of the right hand end of the drain. Well, you can rotate that, so you can orientate it whichever way you need to, depending on which way you need your waste to flow and take it away. So it is adaptable in terms of the way you connect your waste and position the waste. As well as the horizontal waste, we do have vertical waste outlets on these as well. So there's the vertical waste connection with a trap. If you need these, they just need to be specified. They don't come with the vertical waste connection as standard. We supply it with the horizontal one, but we do have the vertical option if you want to take it into take it vertically down to your waste. As I say, we have these in gym box. In Farringdon, I think it is. They've utilised them 2 to 1, so similarly where we see 2 showers into 1 Pipex, you can do the same thing with the drains. Certainly 2 to 1 is quite common, even possibly 3 showers into 1 drain sometimes, depending on falls in the floor and things allowing, and obviously the flow rates, etc. So 2-to-1 is quite common, and we see that at Gym Boxing Farringdon. They've done that. It was a new build gym, so 20 male and 19 female showers. As I say, designed 2-to-1 at a 5.5 per litre minute flow rate. Installed a system B because of the centralised hot water. You see a little bit closer there, the drains kind of straddle each cubicle. So the falls in the floor were designed to allow for 2 cubicles to drain into the one drain. And as I said, system B installation, because of centralised hot water, that was the appropriate installation method. It's quite simple, 2-to-1 with the drain. So just a comparison there of sort of a 1-to-1 and a 2-to-1. Where you take the preheat off the drain, it normally will just go to your cold side of your shower mixer. Here you take it off and then just tee it off to the two different showers. They had the hot water supply coming in from sort of, I think, in the ceiling, and so the hot water dropped down from above, and the cold preheated feed coming up from below from the drains. As I say, 2-to-1 just makes it a really great ROI on these. As I said, ROI won just over a year or so predicted on the Gym Box example. I say the low flow rates and the 2-to-1 installation really helped with that. But we can do these kind of calculations for you. So if you have projects and you have some of the showering data, so expected flow rates, temperatures, and that kind of thing, we can plug that in and we can do calculations for you to give some expected savings. They're the drain systems. They're great, as I say, tiled floors in, say, gyms, leisure centres, that kind of thing. Banks of showers, they're perfect for those. We do have another product, the Recoup WWHRS Active. It's an active version of our standard Pipex. So where the standard Pipex is a gravity-fed system, this is a pump system. It's the only pump system we offer, so it's the only system where we're bringing in an electrical or mechanical component. It could be used in place of something like the drain or the Easy Fit if they couldn't be used for some reason. It just gives another option where you have maybe a ground floor shower, or you can't locate a Pipex on the floor below the shower. A slight compromise in that you are bringing in electrical mechanical component into it, where the systems are generally sort of gravity fed. So there is that sort of slight compromise to it, but you do get the high efficiency benefits of the Pipex, the standard Pipex. It uses the same vertical Pipex heat exchanger, so it is the most efficient heat exchanger we have. So you do get the benefit of that high efficiency. It's very flexible in how it's installed, so hope you might be able to make there that you've got quite a bit of flexibility in terms of distances from the pump can be from the shower waste and then to the actual vertical pipe itself. We can supply all these schematics and drawings for guidance. We have them all available for download, so all of these we can send you if you're designing in, but it is quite flexible in terms of the way it's installed. Obviously you need to get some fall from the shower waste to the pump, so there are things like that to take into account, but it does give you that option of getting wastewater heat recovery in where otherwise it might have been quite difficult. Obviously with a pump you do need have some sort of access there for periodic maintenance. The pipe heat exchanger itself, like the standard Pipex, is maintenance free or planned maintenance free, so that can be boxed away in the same way as the standard Pipex, but the pump does need to be sort of reasonably accessible, so maybe within a vanity unit with an access panel or something like that. And again, 2-to-1 is quite possible, so you can again run 2 showers into one Pipex Active. As I say, if you want help or guidance on that in terms of limitations and flow and things like that, then again just reach out to us and we can help with that. So just a breakdown of the Active there. You might notice on the top there we've got a slightly different turbo rotator. So where the standard Pipex has the turbo rotator on the top, we have this product has a buffer vessel on the top. So what that does is it means the pump pumps up to the buffer vessel and fills the buffer vessel up. The buffer vessel has a turbo rotator built into it, and that directs the flow of water down the heat exchanger in the same way as the turbo rotator would do. So it essentially has got a built-in turbo rotator, but it's also got this buffer vessel on the top. That means the pump only runs intermittently, so the pump only runs about a third of the time that the shower is actually running. It will run at it'll pump at high velocity up to the buffer, fill it up, and then it will stop, and then it will the buffer will drain, the pump will run again, and so on. And so it only runs for about a third of the time the shower is running. So it's a very low wattage pump, so much so that it doesn't actually have any impact on the data, or the PCDB data and efficiencies that go into SAP and SBEM. So the pump is that lower wattage and only runs that little that it doesn't actually have any impact on the efficiency and the impact that the wastewater heat recovery has, the Pipex Active has. So yeah, it's another option. I say slight compromise in that you are bringing that electrical sort of mechanical component into it, but it does mean you can maybe get wastewater heat recovery in somewhere where you wouldn't have otherwise, or get that extra efficiency that you need from the vertical Pipex. That's the product. A non-residential is a newer area for Recoup, fair to say. For a number of years, Recoup really focused on the residential market. Certainly, in the last few years, the non-resi market has become much more prominent. We're seeing waste heat recovery used a lot more. So this is an area we're still trying to learn about a little bit. Is the modelling and the energy modelling for waste heat recovery and how it's included. It's something I'm quite keen to get any input on that you've got. If anyone does modelling for, is trying to do any energy modelling for wastewater heat recovery. But I'll try and give a little bit of guidance on what we understand so far and what we've discovered. So in SBEM, wastewater recovery is available for modelling. It was an update, I think, in version 5.6a. So it's available to model directly in SBEM. It's in the UK NCM data wizard in the showers tab. So there's various criteria data you need to input there. So number of showers, number of shower types. You need to add the whether they have wastewater heat recovery present, whether the shower is located over a bath or not. If the heat recovery is present, a definition of its efficiency. Whether the shower is pumped or not. So really only the active would be the only one with the pump in that case. If the shower has a pump, a definition of the pump's power, and how many individual showers of that shower type are in the building. So if you're doing SBEM modelling, you can input it directly, and that's great. Where it's not so simple, unfortunately, is if you're using DSM modelling, which I think most people probably do for a lot of projects now. The extra complexity and things means that DSM is usually more appropriate, is what I understand. So it's not quite straightforward, unfortunately. So if you use ISVE, then wastewater heat recovery is present in the Apache add-on, the Apache HVAC tool add-on. It's an additional piece of software to the sort of the base software, and it refers to wastewater heat recovery as DWHR. So it is available in there if you have that extra Apache HVAC add-on. In there, you need to specify the number of fixtures and flow rate per fixture for the eligible end users, the modulating profile for consumption pattern, end use temperature, the temperature drop between the end use and the drain side of the domestic DWHR heat exchanger, and the rated effectiveness of the DWHR heat exchanger. So it is in the add-on if you have it. If you don't have the Apache add-on, we do know of people who have used workarounds to build in the impact of the wastewater heat recovery. And there's 2 or 3 different ways you can do that. So we can provide, as I mentioned, we can provide calculations for you in terms of the impact of wastewater heat recovery. So whether that be a kilowatt hour or percentage domestic hot water energy saving data for you, so you can build that in. And then I know some of the things people have done is to put in an artificial domestic hot water energy reduction, an artificial increase in the domestic hot water plant efficiency, or an increase in the incoming cold water mains temperature to account for the wastewater recovery being present. So I know that's been done. I will say, though, that IES, as of our latest communication, don't officially support those methods, although I have experience of people having done that. but unfortunately IIS don't support it. So I can understand that in terms of they've got a software package to sell, so supporting a workaround kind of maybe doesn't make sense to them, but those workarounds have been used previously by people. I can't say IIS supports it though. If you use EDSL TAS software, it's also not present in their software. However, they do support a workaround for it. So they've confirmed that they can supply a calculator to calculate a reduction in the domestic hot water demand equivalent to the wastewater heat recovery installation. So if you contact them, they will supply a calculator for doing that workaround within the TAS software. It is on their development roadmap as well for inclusion, so they do plan to build wastewater heat recovery into future versions of the TAS software, but it really depends how much demand they get for it in terms of how quickly it gets included. So the more demand, the more people they get contacting them saying they want to model wastewater heat recovery, then the quicker it will happen. So please contact them. I'm in conversations with them trying to get it included. So if you can reach out to them as well, that would be great. And also that email address there, that support at email address is how to contact them for the calculator for the workaround. So yeah, do reach out to them. Any help you can get for us to get wastewater heat recovery included natively would be fantastic. So we would like to know also which software you use. So I've mentioned the ISVE there and the EDSL TAS software. In the chat section on here, there is a poll, I think, where you can just vote in terms of which software you use, whether it's one of those or another. It'd be really useful to us to get any feedback on which software you use, and we can continue speaking to those people to try and get wastewater recovery sort of better represented. So if you could vote in that, that'd be great. I mentioned embodied carbon earlier, so Recoup worked with CIBSE to develop their TM65 standard for embodied carbon in residential heating. We use a copper mark, sourced copper, which is 70% recycled and 100% recyclable, and we have a cradle-to-cradle circular model for production, as well as offering a buyback scheme for old or transport damaged products. So rather than just being scrapped, we kind of the materials come back to us and they can be reused. So I said it's a very low carbon product, or low embodied carbon product. If you consider in our vertical pipe system, the most specified product, it has 59 kilograms of CO2 embodied carbon. When you compare that against the annulated calculated savings, so against gas, direct electric, and even air source heat pumps, you can see that the embodied carbon is paid back really quickly. So it's very high SAT points for a very low embodied carbon impact. We have a full suite of sort of support for you. So we have a website where you can get all of the document downloads, all the products we've looked at. We have technical specifications, installation guides, and all the documents that you can want on there, drawings, BIM drawings. We have loads of stuff for download on there, so you can get all the downloads from our website. We have a YouTube page, so this CPD will be on there. Previous CPDs are on there. There's lots of CPDs from my colleague Ellis in the residential CPDs we've done for quite a long time. So there's all that content on there. There's what's in the box videos, installation videos. So there's lots of content on YouTube to look at. We can run CPDs for you if you have a need for a tailored CPD, specific projects, that kind of thing. We can run CPDs, technical and toolbox virtual meetings. We have the room I'm in at the moment set up for doing that. We also have a learning page on the website, so there's lots of courses on there. So if you have contractors or anything like that who are going out installing wastewater heat recovery, they can brush up on their knowledge through the learning site. And we have the space I'm in now, as I said, where we can put together content. We have demo rigs in here, so we have product in here where we can take a GoPro around and show you more detail and that kind of thing. So anything like that we can help with, and we're more than happy to. And lastly, we have the knowledge base as well. So this was something I've been developing since last year, so it kind of answers all the most common questions about wastewater heat recovery. It's got case studies on there and some of the less common questions in terms of designing it in and systems and things. So most questions you've got about wastewater heat recovery will be on there and be answered on there. But it's well worth having a read around the knowledge base. That's linked to directly from our website. So if you go on the homepage of the website, there's a big button there that takes you straight through to the knowledge base. That's pretty much it at the moment. From me, I will add that we have a CPDs for Trees program. So, which I don't seem to have a slide here for, but we essentially will send out copies of the presentation for you, and you'll and there'll be a feedback form. So any feedback form we get, we will plant trees in your name. So something we're doing for quite a while for any feedback forms we get. So please fill in the feedback form and send it back to us. And I say we'll plant some trees in your name. So we'll send you the slides, send you the feedback forms. Yeah, please do that. Is there any questions in the chat or any questions anyone would like to ask?
We've had many questions in the chat, actually. Okay. I do apologise for not being able to keep up with a lot of them. Going back to the first one, really, was to do with calculations for hot water plant reduction and where we'd find such calculations.
Yeah, so the calculations we could do for you in terms of giving you an energy saving calculation. So if you could supply us with the expected hot water use and the showering info, we can then do some calculations to work out the energy saved or the energy reduction that domestic hot water, the wastewater heat recovery would give you to then build in for sort of sizing the plant. So you won't find those calculators online anywhere, but if you get in touch with us, then we can do the calculations with you.
And then one regarding sort of access on the pipe active for the pump.
Yeah, so the pump does need to be accessible, whereas the other systems are kind of all passive gravity-fed systems, so they're generally boxed in behind plasterboard or under a bath, that kind of thing, and they don't need that access. The pump does need to be accessible. The pump's a Saniflow pump. It's a pump that's been on the market for quite a while. It's a grey water pump, so it's a known quantity. It needs to be accessible, but it shouldn't need to be accessed that often. It's difficult to quantify exactly how often it needs to be accessed. A lot will just depend on the use. Saniflow don't specify a time frame. It's just as required. So in terms of frequency of access, it's difficult to say, but the pump element will need to be accessible somewhere. So say you need an access panel or something. The vertical heat exchanger part doesn't, so that's the standard Pipex heat exchanger. That part can be kind of boxed away somewhere, as you would with the regular Pipex. But the pump element, yeah, it does need to be accessible. As I say, that is why it kind of is a slight compromise product in a way, because you've got that pump. But yeah, it's quite flexible in how it can be designed in, as I say, within a vanity unit, that kind of thing with a panel is probably what we normally see.
Fantastic. The last one I can see then, just confirm what data is required to complete a sort of an ROI savings analysis on projects.
So we will want to know the ideally, if you know the delivered hot water temperatures, the shower flow rate, and then we're looking at things like occupancy levels. So if we have things like the number of showers and the expected kind of, if it's a hotel or something like that, an occupancy rate would be good. And we could talk to you about the proposed system type, because the system type will have an effect on the installation in terms of the efficiency of the system. So whether it's system A, B, or C, but I mean we can have a chat about that and see what the most appropriate one would be. But yeah, if you have shower flow rate, shower temperature, the more information you can provide, the better. But shower flow rate, shower temperature, number of shower uses per day, and sort of expected occupancy rates ideally. But just reach out to us and we can have a chat, and I can send you some examples of the kind of stuff we can use. We can make assumptions. So there's things like we can base a lot of stuff on kind of SAP defaults and SBEM defaults for the showering where we don't have data. But yeah, if you reach out to us or we'll reach out and have a chat, we can work the calculations out for you and get them as accurate as we can.
Fantastic. I think we are up to date on the chat then. I will say that I'll keep going through it over sort of next little while and adding the answers to it.
Okay, well, I'm going to hang around for a bit. I'm not in a hurry to go anywhere, so if anyone wants to hang around for a chat afterwards, I'll be here for 10 minutes or so. But yeah, thank you very much.